Hey, welcome to my channel Industry 4.0. In this Python tutorial for beginners video, we will cover the topics: History and development of Python, Python syntax and coding, Python variable and strings, Python math expressions and unfamiliar operators, Python operators, Python lists, Python tuples, Python dictionaries, Python while loops, Python for loops, Python classes/objects, Python modules, file handling in Python. Please like and share the video and subscribe to my channel. So, let's start. Python is a popular general-purpose programming language. It is used in machine learning, web development, desktop applications, and many other fields. Fortunately for beginners, Python has a simple, easy-to-use syntax. This makes Python a great language to learn for beginners. History and development. Van Rossum worked as an implementer of the ABC programming language at CWI, Centrum voor Wiskunde en Informatica, in the early 1980s. Later, when working on a new distributed operating system called Amoeba at CWI in the late 1980s, Van Rossum began exploring a scripting language with a syntax similar to ABC but with access to the Amoeba system calls. As a result, Van Rossum set out to create a new simple scripting language that could overcome ABC's limitations. Van Rossum began working on the new script in the late 1980s, and the first version of the programming language was released in 1991. Modula 3 is the module system used in this initial release. Python was the name given to this programming language later on. Downloading Python. Before we start, we will need Python on our computer. Check whether we already have an up-to-date version of Python installed by entering Python in a command line window. If you see a response from a Python interpreter, it will include a version number in its initial display. Generally, any Python 3.x version will do, as Python makes every attempt to maintain backwards compatibility within major Python versions. Python 2.x and Python 3.x are intentionally not fully compatible. If Python starts a Python 2.x interpreter, try entering Python 3 and see if an up-to-date version is already installed. On Windows, try Py first. This is the relatively recent Python launcher, which has a better chance of avoiding some of the path problems that might occur because on Windows programs don't install into any of the small set of common locations that are searched by default. The Python launcher can also let us select any of the various versions we may have installed from a single command. Windows. The most stable Windows downloads are available from the Python for Windows page. On Windows we have a choice between 32-bit, labeled x86, and in 64-bit, labeled x86-64, versions, and several flavors of installer for each. Mac. macOS from 10.2, Jaguar, to 10.15, Catalina, includes a system version of Python 2, but it is best not to consider this the Python to use for our programming tasks. Install a current Python 3.x version instead. macOS after 10.15, Catalina, will not include a default system Python. Linux. For Red Hat, CentOS or Fedora, install the Python 3 and Python 3 Devil packages. For Debian or Ubuntu, install the Python 3.x and Python 3.x dev packages. For Gentoo, install the equals Python 3.x *e build. You may have to unmask it first. Print command. In Python, the command print tells the program to display words or numbers on the screen. Print, hello, world. Print is a keyword. It means display what's inside the parenthesis. Print isn't capitalized. The parentheses are a special requirement of Python. Quoted text in hello, world, is called a text string or simply a string. Variables. Variables are containers for storing data values. Creating variables. Python has no command for declaring a variable. A variable is created the moment you first assign a value to it. Example: x equals 5. Y equals John. Print x. Print y. Variable for numbers. Unlike a string, a number is not enclosed in quotes. Number can be integer or float. Float 2.3 typecasting. Casting. If we want to specify the data type of a variable, this can be done with casting. Example: x equals str 3 #x will be 3. Y equals int 3 #y will be 3. Z equals float 3 #z will be 3.0. Concatenating text strings. All it takes is a plus sign. We can't use the plus sign to combine strings and numbers. However, if make that number a string, it will work. Data types. Built-in data types. In programming, data type is an important concept. Variables can store data of different types, and different types can do different things. Python has the following data types built in by default, in these categories: text type, str; numeric types, int, float, complex; sequence types, list, tuple, range; mapping type, dict; set types, set, frozen set; Boolean type, bool; binary types, bytes, byte array, memory view; none type, none type. Getting the data type. We can get the data type of any object by using the type function. Example: print the data type of the variable x. X equals 5. Print type x. Python comments. Comments can be used to explain Python code and to make the code more readable. Comments can be used to prevent execution when testing code. Creating a comment. Comment starts with a hashtag, and Python will ignore them. Example: #this is a comment. Print, hello, world. Multi-line comments. Python does not really have a syntax for multi-line comments. To add a multi-line comment, we could insert a hashtag for each line. Example: #this is a comment. #written in. #more than just one line. Print, hello, world. Python Booleans. Booleans represent one of two values, true or false. Boolean values. In programming, we often need to know if an expression is true or false. We can evaluate any expression in Python and get one of two answers, true or false. When we compare two values, the expression is evaluated and Python returns the Boolean answer. Example: print 10 greater than 9. Print 10 equals 9. Print 10 less than 9. Python lists. Lists are used to store multiple items in a single variable. Lists are one of 4 built-in data types in Python used to store collections of data. The other 3 are tuple, set, and dictionary, all with different qualities in usage. Lists are created using square brackets. Example: create a list. This list equals apple, banana, cherry. Print this list. List items. List items are ordered, changeable, and allow duplicate values. List items are indexed. The first item has index 0, the second item has index 1, etc. Ordered. When we say that lists are ordered, it means that the items have a defined order, and that order will not change. If we add new items to a list, the new items will be placed at the end of the list. Allow duplicates. Since lists are indexed, lists can have items with the same value. Example: lists allow duplicate values. This list equals apple, banana, cherry, apple, cherry. Print this list. List length. To determine how many items a list has, use the len function. Example: print the number of items in the list. This list equals apple, banana, cherry. Print len this list. List items data types. List items can be of any data type. Example: string, int, and Boolean data types. List 1 equals apple, banana, cherry. List 2 equals 1, 5, 7, 9, 3. List 3 equals true, false, false. Type. From Python's perspective, lists are defined as objects with the data type list. Class list. Example: what is the data type of a list? MyList equals apple, banana, cherry. Print type MyList. The list constructor. It is also possible to use the list constructor when creating a new list. Example: using the list constructor to make a list. This list equals list, apple, banana, cherry, hashtag note the double round brackets. Print this list. Python collections, arrays. There are 4 collection data types in the Python programming language. List is a collection which is ordered and changeable. Allows duplicate members. Tuple is a collection which is ordered and unchangeable. Allows duplicate members. Set is a collection which is unordered, unchangeable asterisk, and unindexed. No duplicate members. Dictionary is a collection which is ordered asterisk asterisk and changeable. No duplicate members. Python tuples. Tuples are used to store multiple items in a single variable. Tuple is one of 4 built-in data types in Python used to store collections of data. The other 3 are list, set, and dictionary, all with different qualities in usage. A tuple is a collection which is ordered and unchangeable. Tuples are written with round brackets. Example: create a tuple. This tuple equals apple, banana, cherry. Print this tuple. Python dictionaries. Dictionaries are used to store data values in key value pairs. A dictionary is a collection which is ordered asterisk, changeable, and do not allow duplicates. Dictionaries are written with curly brackets and have keys and values. Example: create and print a dictionary. This dict equals brand, Ford. Model, Mustang. Year, 2022. Print this dict. Dictionary items. Dictionary items are ordered, changeable, and does not allow duplicates. Dictionary items are presented in key value pairs and can be referred to by using the key name. Example: print the brand value of the dictionary. This dict equals brand, Ford. Model, Mustang. Year, 2022. Print this dict, brand. Python conditions and if statements. Python supports the usual logical conditions from mathematics. Equals, A equals B. Not equals, A equals B. Less than, A less than B. Less than or equal to, A equals B. Greater than, A greater than B. Greater than or equal to, A equals B. These conditions can be used in several ways, most commonly in if statements and loops. An if statement is written by using the if keyword. Example: if statement: A equals 33. B equals 200. If b greater than a. Print, b is greater than a. Indentation. Python relies on indentation, whitespace at the beginning of a line, to define scope in the code. Other programming languages often use curly brackets for this purpose. Python while loops. The while loop. With the while loop we can execute a set of statements as long as a condition is true. Example. Print I as long as I is less than 6. I equals 1. While I less than 6. Print I. I plus equals 1. The break statement. With the break statement we can stop the loop even if the while condition is true. Example. Exit the loop when I is 3. I equals 1. While I less than 6. Print I. If I equals 3. Break. I plus equals 1. The continue statement. With the continue statement we can stop the current iteration and continue with the next. Example. Continue to the next iteration if I is 3. I equals 0. While I less than 6. I plus equals 1. If I equals 3. Continue. Print I. The else statement. With the else statement we can run a block of code once when the condition no longer is true. Example. Print a message once the condition is false. I equals 1. While I less than 6. Print I. I plus equals 1. Else. Print I is no longer less than 6. Python for loops. A for loop is used for iterating over a sequence, that is either a list, a tuple, a dictionary, a set, or a string. This is less like the for keyword in other programming languages, and works more like an iterator method as found in other object-oriented programming languages. With the for loop we can execute a set of statements, once for each item in a list, tuple, set, etc. Example. Print each fruit in a fruit list. Fruits equals apple, banana, cherry. For x in fruits. Print x. Looping through a string. Even strings are iterable objects, they contain a sequence of characters. Example. Loop through the letters in the word banana. For x in banana. Print x. The break statement. With the break statement we can stop the loop before it has looped through all the items. Example. Exit the loop when x is banana. Fruits equals apple, banana, cherry. For x in fruits. Print x. If x equals banana. Break. The continue statement. With the continue statement we can stop the current iteration of the loop and continue with the next. Example. Do not print banana. Fruits equals apple, banana, cherry. For x in fruits. If x equals banana. Continue. Print x. The range function. To loop through a set of code a specified number of times, we can use the range function. The range function returns a sequence of numbers starting from 0 by default and increments by 1 by default and ends at a specified number. Example. Using the range function. For x in range 6. Print x. Else in for loop. The else keyword in a for loop specifies a block of code to be executed when the loop is finished. Example. Print all numbers from 0 to 5 and print a message when the loop has ended. For x in range 6. Print x. Else. Print finally finished. Nested loops. A nested loop is a loop inside a loop. The inner loop will be executed one time for each iteration of the outer loop. Example. Print each adjective for every fruit. ADJ equals red, big, tasty. Fruits equals apple, banana, cherry. For X in ADJ. For Y in fruits. Print X, Y. The pass statement. For loops cannot be empty, but if you for some reason have a for loop with no content, put in the pass statement to avoid getting an error. Example. For X in 0, 1, 2. Pass. Python functions. A function is a block of code which only runs when it is called. We can pass data, known as parameters, into a function. A function can return data as a result. Creating a function. In Python, a function is defined using the def keyword. Example. Def my_function. Print hello from a function. Calling a function. To call a function, use the function name followed by parenthesis. Example. Def my_function. Print hello from a function. My_function. Arguments. Information can be passed into functions as arguments. Arguments are specified after the function name, inside the parentheses. You can add as many arguments as you want, just separate them with a comma. The following example has a function with one argument, fname. When the function is called, we pass along a first name, which is used inside the function to print the full name. Example. Def my_function, fname. Print fname plus refsna. My_function, Emil. My_function, Tobias. My_function, Linus. Keyword arguments. We can also send arguments with the key equals value syntax. This way the order of the arguments does not matter. Example. Def my_function, child 3, child 2, child 1. Print, the youngest child is plus child 3. My_function, child 1 equals Emil, child 2 equals Tobias, child 3 equals Linus. Python classes and objects. Python is an object-oriented programming language. Almost everything in Python is an object, with its properties and methods. A class is like an object constructor, or a blueprint for creating objects. Create a class. To create a class, use the keyword class. Example. Create a class named myClass, with a property named X. Class myClass. X equals 5. Create object. Now we can use the class named myClass to create objects. Example. Create an object named P1 and print the value of X. P1 equals myClass. Print P1.x. The __init___ function. The examples above are classes and objects in their simplest form, and are not really useful in real-life applications. To understand the meaning of classes, we have to understand the built-in __init__ function. All classes have a function called __init__, which is always executed when the class is being initiated. Use the __init__ function to assign values to object properties or other operations that are necessary to do when the object is being created. Example. Create a class named person. Use the __init__ function to assign values for name and age. Class person. Def __init__ self, name, age. Self.name equals name. Self.age equals age. P1 equals person, John, 36. Print P1.name. Print P1.age. Object methods. Objects can also contain methods. Methods in objects are functions that belong to the object. Let us create a method in the person class. Example. Insert a function that prints a greeting, and execute it on the P1 object. Class person. Def __init__, self, name, age. Self.name equals name. Self.age equals age. Def myfunc, self. Print, hello my name is plus self.name. P1 equals person, John, 36. P1.myfunc. The self parameter. The self parameter is a reference to the current instance of the class, and is used to access variables that belongs to the class. It does not have to be named self, you can call it whatever you like, but it has to be the first parameter of any function in the class. Example. Use the words missillyObject and ABC instead of self. Class person. Def __init __, missillyObject, name, age. MySillyObject.name equals name. MissillyObject.age equals age. Def myfunc, ABC. Print, hello my name is plus abc.name. P1 equals person, John, 36. P1.myfunc. Python modules. Consider a module to be the same as a code library. A file containing a set of functions you want to include in your application. Create a module. To create a module, just save the code you want in a file with the file extension .py. Example. Save this code in a file named mymodule.py. Def greeting, name. Print, hello, plus name. Use a module. Now we can use the module we just created by using the import statement. Example. Import the module named mymodule and call the greeting function. Import mymodule. Mymodule.greeting, Jonathan. Variables in module. The module can contain functions, as already described, but also variables of all types, arrays, dictionaries, objects, etc. Example. Save this code in the file mymodule.py. Person1 equals name, John. Age, 36. Country, Norway. Naming a module. We can name the module file whatever you like, but it must have the file extension .py. Renaming a module. We can create an alias when you import a module by using the as keyword. Example. Create an alias for mymodule called mx. Import mymodule as mx. A equals mx.person1 age. Print a. Built-in modules. There are several built-in modules in Python, which you can import whenever you like. Example. Import and use the platform module. Import platform. X equals platform.system. Print x. Import from module. We can choose to import only parts from a module by using the from keyword. Example. The module named mymodule has one function and one dictionary. Def greeting, name. Print, hello, plus name. Person1 equals name, John. Age, 36. Country, Norway. File handling in Python. Python also supports file handling and allows users to handle files, i.e., to read and write files, along with many other file handling options, to operate on files. The concept of file handling has stretched over various other languages, but the implementation is either complicated or lengthy, but like other concepts of Python, this concept here is also easy and short. Python treats files differently as text or binary, and this is important. Each line of code includes a sequence of characters and they form a text file. Each line of a file is terminated with a special character, called the EOL or end-of-line characters like comma, comma, or new line character. It ends the current line and tells the interpreter a new one has begun. Let's start with the reading and writing files. Identifying data inside .data files. .data files come in two different variations, and the file itself is either in the form of text or in binary. Testing, text file. .data files may mostly exist as text files, and accessing files in Python is pretty simple. Being pre-built as a feature included in Python, we have no need to import any module in order to work with file handling. Working with CSV files in Python. While we could use the built-in open function to work with CSV files in Python, there is a dedicated CSV module that makes working with CSV files much easier. Before we can use the methods to the CSV module, we need to import the module first using import CSV. Reading CSV files using csv.reader. To read a CSV file in Python, we can use the csv.reader function. Suppose we have a CSV file named people.csv in the current directory with the following entries: name, age, profession. Jack 23 doctor. Miller 22 engineer. Let's read this file using csv.reader. Example 1, read CSV having comma delimiter. Import CSV. With open, people.csv, r, as file. Reader equals csv.reader, file. For row in reader. Print, row. Output. Name, age, profession. Jack, 23, doctor. Miller, 22, engineer. Here, we have opened the people.csv file in reading mode using with open, people.csv, r, as file. To learn more about opening files in Python, visit Python file input output. Then, the csv.reader is used to read the file, which returns an iterable reader object. The reader object is then iterated using a for loop to print the contents of each row. Python JSON. JSON, JavaScript Object Notation, is a popular data format used for representing structured data. It's common to transmit and receive data between a server and web application in JSON format. In Python, JSON exists as a string. For example, P equals name, Bob, languages, Python, Java. It's also common to store a JSON object in a file. Import JSON module. To work with JSON, string, or file containing JSON object, you can use Python's JSON module. You need to import the module before you can use it. Import JSON. Parse JSON in Python. The JSON module makes it easy to parse JSON strings and files containing JSON object.